The School of Landscape Architecture here at the Boston Architectural College. The BAC has been recognized with distinction for its leadership role in educating an extraordinarily diverse student body, such as many of you, to help bring about social equity through the design of landscapes, buildings, interior architectures, historic preservation, designs for human health, and much more. I'd like to welcome all of you this evening to the Spring 23 lecture series, Just Environments. Tonight, it is my pleasure to introduce Pamela Conrad. Pamela is an internationally recognized landscape architect and climate advocate. Her passion for the environment is drawn from her early years growing up in a Midwestern farm, her studies in plant science, and interest for regenerative architecture, landscape architecture, and large-scale habitat restoration. Her research on improving carbon impacts of the built and natural environments is elevating landscape architecture's positive contribution to climate change and informs her work as founder of Climate Positive Design. Pamela is vice president of the International Federation of Landscape Architects, IFLA Climate Change Working Group, who spearheaded the IFLA Climate Action Committee commitment presented at COP26. Pamela is also the chair of the American Society of Landscape Architects Climate Action Plan shared at COP27. She is senior fellow at Architecture 2030 and a 2018-19 Landscape Architecture Foundation fellow for innovation and leadership. Her work has been featured in Time Magazine for Kids, Curbed, City Lab, Landscape Architecture Magazine, and she is a recent contributor to Build Beyond Zero. Conrad speaks internationally and has been recognized with the San Francisco Business Times Women of Influence Award, ASLA's Award of Honor, and the Metropolis Magazine Planet Positive Award, among many, many other awards. Pamela is currently a Loeb Fellow at Harvard Graduate School of Design. Please join me in extending a warm welcome tonight for Pamela Conrad as she presents her lecture entitled Climate Positive Design, Going Beyond Neutral. Thank you.
Well, thank you, Maria, for the warm welcome and for all of you joining us here tonight. It's my honor and I'm excited to share with you some of the ideas behind climate positive design. So that was a great introduction, so I don't have to say much more to introduce myself, but maybe just touching on the thing that I think is most important to me is that I was a farm girl raised in Missouri, and it's that deep appreciation of nature that I gained early on that inspired me to become a landscape architect and care about the climate issues that we're facing today. So I've been practicing as a landscape architect for about the past 20 years, and the last 10 of which have been focused on helping cities to become more resilient in the face of climate change. So working on redevelopment projects in the San Francisco Bay Area, such as the Treasure Island redevelopment project. And then on the other side of the water in San Francisco, working with the Port of San Francisco to help adapt 7.5 miles to looming earthquakes and sea level rise in very diverse conditions along its urban developed waterfront. And so it was working on projects like this that started to make me wonder about what is the impact of these large projects that we worked on all scales, but what are we actually causing? You know, we've been working on sea level rise adaptation projects to try to respond to these effects, but what is our contribution? And so in digging in, we understand today from UN Habitat that the urban built environment is responsible for about 75% of urban global greenhouse gas emissions. That's what's causing temperatures to rise and sea levels, increased fires and decrease in air quality. And that's a lot. And so about 40% of those are coming from buildings, but the other 36% are coming from outside of buildings in the spaces that landscape architects and civil engineers and planners create, the area that I've been focusing on. And there are a couple different factors in how we understand those emissions. It's coming from the embodied carbon emissions from the materials we use in our projects. So it's the extraction, the manufacturing, the transportation, the construction of those materials on site. It's also the operational carbon emissions. So using things like gas-powered equipment to manage landscapes, or using chemical fertilizers that can contain greenhouse gases that happen over time in the lifespan of a project. And then what's really unique about the exterior built environment that includes landscapes, trees and plants and soils that can actually sequester or take down carbon dioxide, the largest greenhouse gas, from the atmosphere and sink it into the ground where it belongs. And understanding that picture, we can start to ask ourselves, how do we reduce those emissions? Can we sequester more? And how are we going to measure this? So through the natural process of photosynthesis, trees and plants can take carbon dioxide into their leaves and woody material, and then convert that as it's where they draw their energy and sink it into the soil below. That logs it down into that overall, over time, fossil carbon, that's oil, natural gas, and coal that we are continuously digging up and burning. So now you have that carbon that's mixing with oxygen in the atmosphere, creates CO2, and that's this greenhouse gas that's causing this thickened layer in the atmosphere, which is causing global warming. And the issue that we're facing right now is we put so many greenhouse gases into the atmosphere that we're at a point in time right now that we have about a 340 gigaton budget left of emissions, greenhouse gases that we can put into the atmosphere before we hit this 1.5 degree temperature threshold, to the point that it starts becoming irreversible. And so what we're working towards right now is we understand what this budget is, and what it means is we have to draw down those emissions. So we need to get to 65% by 2030, or 50%, I heard from the IPC on Monday, but 65 would be better by the year 2030. And then we need to get to zero overall emissions by 2040. And why this temperature threshold matters is because that 0.5 degree temperature increase from the 1.5 degree increase to the 2 degree increase can prevent us from having billions of people that will otherwise be exposed to severe heat waves, millions of people that will otherwise be at risk of hunger, and billions of people that will no longer have adequate water or be forced to migrate. And these will largely be impacted by those that have contributed the least to these to climate change, and also in communities of color. And so, as I'm sure you've been hearing about, that climate change is not just, is that there's an opportunity for us to step up into this crisis that we're facing. Now, we've known for a long time that there are some general strategies that we can think about and how we can reduce these carbon footprints in the spaces that we design collectively. So there are ways to reduce those carbon footprints, like designing cities to be more walkable and more bikeable. We can reduce the emissions that come from making concrete by using cement substitutions. We can also minimize soil disturbance and use local and reclaimed materials. And we can also make everything greener. So we can use materials and plants that sequester more carbon, like bamboo or shrubs instead of lawn areas. We can add green roofs and generally as much as green wherever possible, and then protect and restore our natural ecosystems like forests and mangroves and coastal wetlands and seagrasses. And so going back to the question that I had just a minute ago about, how do we understand these impacts, or how are we going to measure them? So about 5 years ago, a landscape architect working at my desk on this couple-acre park project, I thought, well, what is the carbon footprint of this project? I think it's really sustainable, where we have sustainability principles in mind, and everything we do, I can't imagine how it could be any better for the environment. But when I started to ask that question, I thought it would be something I would probably just go online and find a tool that afternoon, answer my question, then I would be done and I would move on from things. But the reality is 5 years ago, that tool didn't exist. And so just out of frustration and a bit of Missouri farm girl stubbornness, I started to build a tool that could help me understand this sort of building equation side, the emissions, but also the landscape side, this ongoing positive impact that we have. And so what I found when I started to make this really crude spreadsheet with random sources from all over the place was that my couple-acre park project, that you can see the amount of metric tons emitted on the lower left-hand corner and the amount of CO2 that would be sequestered, it would take about 15 years for this project to offset its own carbon footprint. And I thought, that seems like a lot. It's a really green project. I don't know what to do, how to make it better. But when I started to have those numbers in front of me and I could see where those emissions were coming from, I realized that I could have made smarter changes in the materials that I used and how I designed that site that still allow the programming to function and the quality to still be good, but instead of it taking 15 years to offset its carbon footprint, it could have been done in 5. And generally across the board, cutting emissions in about half, doubling sequestration. And that was accomplished by choosing materials that have lower embodied carbon, so the less emissions that it takes to make a material, adding some trees, converting some of the lawn areas into shrubs, and looking at our ongoing maintenance and how, whether that would be electric or gas-powered equipment. So ultimately, going from 15 to 5 years, you can't really see the difference, but it's just much better for the environment. And so this pattern continued. I started doing case study after case study. Well, what about different kinds of projects? And what I was really shocked to find is this little half-acre plaza would take almost 200 years to offset its carbon footprint. And again, this was designed with sustainability principles in mind. But what happened again and time again is that this, instead of taking 200 years to offset its carbon footprint, it could have been done in 20. And again, just by using some different materials, adding some trees, using more planting instead of paving, cement substitutions. And again, the project performs the exact same way it did before. It has the same quality, the same aesthetics, but much better carbon footprint. And so this was eye-opening to me. But I realized it's not going to make a difference if just I change the way I design, or maybe just my firm changes the way it designs. We need to change our whole business as usual as an entire profession around the world. And so what if we can go from our current business as usual, which is the graph on the left, which would show that we're net emitting more, we're emitting more than our projects are sequestering over time, and that's actually adds up to a significant amount. Instead, if we made all those little small changes that I showed you in those case studies, we could be at the graph on the right. And so we could actually reverse that curve. Instead of being a net emitter, we could be net positive and take almost a gigaton of CO2 out of the atmosphere in the coming decades. And we could be part of not just offsetting our carbon footprints and offsetting our negative impacts, we could be part of a positive solution. And that gigaton would put this initiative effort with landscape architects around the world in the top 80 solutions in Project Drawdown. And if you're familiar with that initiative and effort, what it shows you is when we combine around 80 solutions globally, what we can start to do is actually draw down greenhouse gases in the atmosphere collectively over time to the point where we could reverse global warming. And so this is why this matters. With this information, I realized that we all need some guidance in this area. And so I launched the Climate Positive Design Challenge in 2019 with the idea of setting targets for everybody to meet for their projects to offset their own carbon footprints, with the goal of getting to net positive, not just carbon neutral. That's not really an ambitious goal for us, just offsetting our bad impacts. It's actually a much better goal to be positive and be part of the solutions. So the challenge sets targets for projects to offset the years that it would take to offset their project, so they can get to that point of being positive. So it's set for 5 years for projects that are like greener inherently, gardens, parks, campuses, hospitality, and 20 years for projects that are more urban, like plazas and streetscapes, for example. And the goal is, if we're meeting those targets, you're basically cutting your emissions in about half, doubling sequestration. And so it's that collective impact that could have this overall positive impact on the planet. And to meet the goals of the challenge, at the time, it was through the Landscape Architecture Foundation Fellowship, I was able to get some support to help develop this app called the Pathfinder. And it's grounded in a few different principles. Through this fellowship process, I had the great opportunity to have some really kind and supportive fellows working with me. And I asked them, I said, well, what would it take for you to change the way you design? And they told me 3 things. They said, 1, it would have to be easy and quick. 2, it'd have to sort of work within my existing work stream of how I design. And 3, I'd have to see that the changes that I was making were making a difference. So I needed to get some sort of feedback. And so that's how we developed the app. The baseline data is coming for materials from the Athena Impact Estimator, and most of the sequestration data is coming from the US Forest Service. And so it's really simple. I'm going to walk you through it, but basically you provide some quantities for your materials for your projects, also planting quantities, and then your plans for operation over time. And it's always giving you this years to positive score. So how much time does it take to offset those impacts that we've had? So I'm just going to walk you through this, and it will go fast. But when you get to the website, go to the Calculate tab and click Use Pathfinder. And you get started. It gives you this little demo and to explain what we mean by being climate positive. The two main factors, that there's the carbon that we're emitting and the carbon that we're sequestering. And the relationship between the two, that the more we emit, the more time it takes to offset that carbon footprint, and the more we sequester, the less time it takes. So your goal is you have to ultimately do both to meet the goals of the challenge. So when you're working on a project, you can type in your address of your project site anywhere in the world, and it takes you to that site and kind of a rough map. You can modify this later. It doesn't have to be perfect. You're just kind of defining your general site boundaries that you're working within. So once you get in there, we're going to downtown Los Angeles today. You use the polygon tool to draw the outline of your site boundary. And so you just click using the tool like it's shown here. And once you get that, you can always make it more accurate later. You can just check the box to go forward. And then once you continue with that, all you need is an email address to set up an account to measure your project. So you want to get in there and give some basic parameters of your site. Again, anything you enter in at this beginning stage, you can edit later. So no worries what you put in. You can say like, this is my mom's house or whatever, and you can fix that later. So you want to select your project type, its estimated completion date. And then once you get that, your units, phase your project is in, if you're pursuing any of these certifications. And if you're a student, click the box at the bottom, because that's going to exclude your project from our overall professional contributions. Once you get in here, you can understand existing conditions of the site or your design alternative, and you can do as many alternatives as you want. So you hit create, and once you get in here, you can search for materials by using the drop down or the search. And then once you get in here, you'll see it's pretty straightforward. There's 80 to 100 different materials. You select the one that you want to add for your project. You can see it's a range of concrete, asphalt, gravel, the basics, steel and aluminum. And then so what you do is you look for what you're adding for your project. It pops up on the right side. You give it some basic parameters for the area. And then what you see is the red number pops up. That's the amount of emissions for that specific material that you selected. If you don't see something in here, you can create a custom material and add it on your own. And then you just keep going. And how you would add something on your own is you would get an environmental product declaration and you add in the global warming potential number. So we can talk more about that as we wrap up, but just so you know, that's how you would do it. So you continue to add materials in. You can even start as early as possible in a project. I recommend even in the concept phase, even if you just have a sketch on a napkin, get some area takeoffs and plug it in and start to understand, you know, what's causing the main, you know, the kind of big offenders, just to get started. So again, you continue plugging away. It gets down into detail things like mulches and soils, and you know, it continues to build up your overall emissions impact. The second tab is the plants tab. So you can see there's a range here from trees, shrubs, lawns, grasses, perennials, wetlands, forests, that kind of stuff. And then once you select your quantity here, you'll see a couple of things. One, you selected your growth zone because this is regionally specific data. And then once you added that medium tree, the green number is the amount that those trees are sequestering over a 50-year lifespan. And the number on the right, and you'll see this happens with shrubs too, pops up down below, and you'll see your years to positive score continues to improve on the lower right-hand corner. So again, you keep plugging away. As I mentioned, operations, that would be things like what kind of equipment are you using? Are you cutting down trees? Are you moving or disturbing soil? So again, you just add in the quantities of those things, and that shows you the red number of the emissions. And at the bottom, you'll see there's a design suggestions tab. So this is specific to everything you enter, and it gives you recommendations for alternatives to consider that would have a lower carbon footprint. So that's a good place to get started. You can also go to the version stats and view your scorecard. And it shows you, kind of breaks down everything you just entered. It shows you so you can compare where the most emissions coming from. And it shows this on that second page of the scorecard, how they stack up and compare to each other. So you hit the back button and it takes you back to your home page, which again, you can edit any of those things anytime. And then if you're doing like a studio project or your firm's project, you can enter it all in here in your one account, and you can see all of your projects. You can learn from each other, maybe your classmates or your workmate, so you can see how are we doing collectively. So that's the tool. And so why are we doing this? What does measuring do for us? Well, once we start to measure, it creates a feedback loop. So we start to get feedback and understanding the choices for our design. So it evolves, it helps us to evolve over time and inform how we design, how we practice, how we advocate, educate, and communicate going forward. And it helps us shift from where I was at that moment in time when I was just wanting to improve my own project, my individual impact, to everyone doing this and us having a collective impact together. And of course, I work to wrangle and bring as many people into this initiative as possible. So this is only possible with volunteers and dedication from many other passionate individuals. And of course, advisory partner organizations that support the initiative over time as well. And so it's been about 3 years since I launched this initiative. And the great thing is that we can start again by collecting data. We can learn from our progress. How are we doing? What do we need to work more on? And so, for example, for this first 3 years, just to think about step one, when we weren't aware of this at all 5 years ago, the first step is just increasing awareness, getting people to log their projects, recognizing everybody as contributors. And so putting out resources for everybody to use that are free and accessible. So to date, there's about 175 countries reached. So that's 90% of the countries around the world have accessed the website and the web resources, which I encourage you all to do. It's climatepositivedesign.com. And also seeing that we have about over 5,000 projects logged into the app to date. And so that's been great to see. Just even in this past year, that's been an increase in 50%. From the overall projects, and also 35% increase in contributors. So anybody that logs a project is considered a contributor. So that's like gold star, yay, confetti, good job. You're taking the first step in understanding this. And of course, by getting out there and sharing this with others, which all of you can do too, is part of that increasing awareness. And then also understanding, okay, well, what are our actual impacts? So what are those projects that we know are going to get in the ground, they're getting built, they're going to be seen all the way through? Do people log all the full information? And so that amount of projects is around 800 projects. And so we can start to see is to learn from those and say, what's their overall impact? And so today, those projects are estimating planting about 1.7 million trees. And their net positive impact is about 2.3 million metric tons removed by 2040. And that's about the equivalent to taking around 500,000 cars off the road. So I know that that number doesn't mean that much. When you think about how hard it is to take 500,000 cars off the road, it's pretty hard. So that's kind of that equivalent of our impact by 2040. And then we can also start to learn, what are we improving on? What do we need more work? And so one thing is that we understand that about 75% of our emissions are coming from the materials. And so that's an area that we can target right now. We can immediately work with manufacturers. We can specify different products. And so that's definitely something we can take on and focus. We also see that it's this great progress this past year that we've reduced emissions in the projects by about 12%. And so if you think about that number that we've got to get to, so we're talking 50 to 65% emissions reductions by 2030. If we start doing this like 12% per year improvement, that's going to get us there pretty close. And so it's not that it has to happen overnight. We can't stop emissions immediately, although I think we all know we need to, but it's also understanding, that we can start this incrementally, and that's going to add up over time. I think some of the other things is just diving into the materials again. Now we can start to understand, okay, well, what are our biggest offenders? Those are typically concrete, metals, and stone. So concrete, we can start to use cement substitutions, the process. So instead of using cement, there's a number of different substitutions that we can use in place that don't have the energy intensity required to make them that cement does. We can also use recycled aggregates, whether it's what goes below the concrete or what gets mixed into the concrete. There's also carbon sequestering concrete out there today, where they take it from factories and actually pump it in to the concrete itself. So it's storing that carbon versus releasing it back up into the atmosphere from factories. And then, some of these things we know are best practices, but maybe we haven't been pushing hard enough for them. So like metals, we can maximize the recycled content. And then for stone, a lot of stone gets imported all the way around the world to be used. And so if we can just even use locally sourced stone, we can reduce emissions by about 15 to 20% by using a local stone instead of one that's coming from around the world. There's also a lot of other great alternatives for paving materials that are listed here as well. So it's good to see that there are more manufacturers coming along with this trend as well, because they understand that the way for us to succeed is for them to help us. And that's a good business model. Excuse me for just a second. So shifting gears a little bit, I think at this point in time, we are starting to understand these principles. We're starting to implement them. And the great thing is when we start them really early, we can really scale up these positive impacts. And so this is an example. I spent the last 5 years working with the Port of San Francisco and San Francisco's waterfront resilience program. And you can see here in this map, the coastal and inland flood risk by 2100. And so that's all the colored areas in the shoreline. So it's really significant. It basically goes up all the way to the historic shoreline where there wasn't fill before. So it's very similar to Boston in that way. All the fill in the areas around here, that's what's going to get flooded first. And just as I mentioned, the conditions around the waterfront change so much over time, also like Boston's waterfront. So very urban conditions, areas where people are living in houseboats on the water, industrial areas that support port maritime facilities. And so the great thing is that through that process of 5 years, and hearing from the community and working with the city agencies, what came about is that people really care about nature and are starting to see the benefits of nature-based solutions. And not only can we protect from future sea level rise or adapt in a way that's resilient over time, but we can also, using these nature-based solutions, sequester carbon and support biodiversity and clean the water. So many things. So there's great examples around the world where using nature-based solutions on living shorelines are starting to become implemented, and San Francisco is aspiring to also have that be the future of their waterfront. And so just wanted to share a few examples, the strategies that were developed over the last 5 years. It's wonderful that nature-based solutions are incorporated into many of the options. These are actually all available on the port's website if you're curious to see more. They're out for public comment right now. But some of the things you can start to see are where nature-based solutions have been incorporated, including vegetation. Over time, that's going to be supporting habitat and protecting some of the inland uses. And then also looking at areas where we can start to have that softer edge that are going to support various habitat conditions, as well as looking at how we might reduce the roadway widths to provide more space for more gradual adaptation options versus putting in very structural conditions like seawalls that are very concrete intensive and will have very, very large amounts of embodied carbon emissions. And as part of this process, we also realized too that if we want to have more gracious living shoreline conditions, we may have to embrace adding some fill to the bay, which does not meet current regulations. So to embrace these conditions of a sustainable waterfront edge that sequester carbon and support habitat, we might actually have to work with officials to change policies that will allow bay fill that can support these shoreline conditions. And again, not only looking at opportunities where we can expand into the bay, that's not ideal. We would rather protect existing water bodies, but we're looking at areas where we could actually start to pull back that shoreline that would maybe be less impactful. But of course, we have to think about things like environmental justice and making sure that we're not impacting communities in a negative way. So I have to think through all those different aspects of including these nature-based solutions. And then again, also thinking about how we're going to address these inland flooding conditions from stormwater or groundwater rise as well, and treating those runoff conditions, again, that support carbon sequestration and habitat and a healthy bay. And then across the water from Treasure Island, we're also looking at different conditions. This is in a former naval base site, reimagining a tarmac that looks very different than this image, and how it can be a model for climate positive resilient landscapes going forward. So even through the pandemic, we met with local community members to hear about their needs and concerns. This is actually the site itself. And the primary ideas for the site were to keep everything on the site that exists there today, but reconstruct it in a way that makes more sense for all the things that we've been thinking about and talking about. So removing and repurposing the riprap, and then creating subtidal habitats with that repurposed material, repurposing the concrete slabs that are on the existing tarmac, and then recycling the asphalt and building up landforms and overlooks. So the idea also is that the site will be one condition when it is implemented in the coming years. And then it's also going to be designed in a way to embrace sea level rise and change over time. So the project as it exists today in its current condition can be transformed into something like this that sequesters carbon, supports habitat, and it offsets its own carbon footprint in 4 years, which is pretty fantastic through the strategies that I was mentioning. And then as sea levels continue to rise, that the wetland will migrate inland over time and continue to serve its function. Now, those were local projects that I was involved with, but it's also fantastic as this is a global initiative to start seeing from other people how they're using these tools and resources. So this is from a firm in the UK, and they talked about how using the climate positive approach and tool helped them have conversations with their client about maybe changing some of the preconceptions that they thought their site would be, but with their goals of getting to 8 years to positive, they were able to sort of have that conversation along the way in the process. And some of those ideas shifted and they were embraced by the client and the project team. They also took those strategies and applied them to an entire regional park network and look at all the different pieces of the puzzle and how they affected each other and the overall impact that they were having. And another project in Spain, wonderful to see these projects actually being implemented on the ground and seeing that by, their project that offset its carbon footprint in 16 years also supported some other considerations for resilience. So using low water usage plants and preventing other anticipated events that they expect in their region due to climate change. So I know that was a lot for everyone to digest, especially if this is a new topic to you. But I think it's also helpful to keep in mind. There's really 5 top things that we can do when we're trying to reach this goal of being climate positive on our projects. We can first make sure that we are increasing planting. Just that one idea of plant more and pave less can get you a long way. So we want to maximize that carbon that's stored in the plants in the soil. And so some of those strategies include using planting that's going to be fast growing, long lived, has a long growing season, and ideally low maintenance. So we're not using a lot of emissions and energy to maintain it. Also, like I said, minimizing paving. So minimizing the hardscapes. We've paved paradise at this point in time. So we need to really kind of take a step backward and how do we get back to more natural systems that work and integrate together. And as I mentioned, some of the materials that have the most emissions are concrete, metals, that imported stone. We can also think about using more natural grading strategies. So we don't have a lot of piping that's running underneath our feet that we don't even see, which actually has a lot of emissions in it when you start to add it all up. And then I mentioned some of these other strategies about cement substitutions, using recycled materials. And then being smart about our materials selection. And so, like I said, when you start to see all these things and how they compare to each other, it's surprising what a big difference that they have in terms of the emissions, one material over another. So looking at those things, thinking about them, using locally sourced materials, and advocating for manufacturers, the transparency in how much emission goes into making this chair or this panel, right? So it's time for us to start understanding that, but it does require an openness from the product manufacturers for us to be able to know that information. And then also, it's important that this is part of our design process and it makes it into our drawings. It's also really important that it makes it into our specifications and that it gets built and implemented the way that we had intended. And so a couple ways you can do that is making sure when you draft your specifications that it includes and addresses things like what are listed here. And then over time, if you plant a native landscape, for example, you don't want it to be pruned into a hedge, right? And so you have to write that information into your specifications to make sure, you know, the day that you walk away, it doesn't happen, right? And so getting that into your specs. And then operations and maintenance manuals is also another place where you can document that and you can work with your client and leave them with this manual that can get passed to the maintenance crew. Or you can, even better, work with the maintenance crew to develop it so everybody really understands the intent and they're on board with implementing that over time. So beyond, you know, I think I've talked a lot about what you can do on projects as designers, but there's also so much that we can do as advocates as well. All these things, we need support from the policy level. We need support from our cities and municipalities to help also make this part of the requirements, so guidelines and standards and codes going forward. And so I've been doing what I can to work with these agencies or certification systems to help write new LEED and CITES credits, working with the City of Toronto on their new green building standards. As Maria mentioned, I'm contributing author to the Build Beyond Zero book, which all the things I'm talking about are in much more detail. You can probably digest them a little bit easier that way. And then the climate action plan effort that I led this past year with the ASLA, you can also download that resource and the field guide and get that online. And it's like a 100-page document. You can go through it, keep it on your desk. It's a really great reference. And so the idea is just getting this out there in as many ways as possible. And of course, then that advocacy goes beyond just a certain discipline, but we have to work interdisciplinary. So some of those efforts are working with the architecture community, supporting some of the initiatives that Maria mentioned at COP26 communique. And so really trying to bring people together to advocate for the same things. So we can be much more effective when we're working together with common goals. And then again, aligning the landscape architecture profession as well and commitments. And these are a bunch of pictures of me talking to a lot of people, but that's part of it, is just us talking about this, us getting the message out there, helping people. And they may not understand that we need codes that are set for how we build things. And so we understand those things and we can help them to write those things to help us lower embodied carbon, to implement nature-based solutions. And I think there's there's definitely a groundswell around people wanting to get involved in the advocacy space. So I hope you feel like you have the opportunity to get involved as well, because it's really clear what we need to do. Coming out of COP27, there's a very clear implementation plan. We know all the solutions. We just need to implement them. So we need everybody that's involved in any way to get involved and take action. And so for you, there's lots of different ways that you can get involved. So if you're an educator or a student, I hope you feel like you can use the resource climatepositivedesign.com. The Pathfinder tool is there. The challenge is listed out there for you to better understand. There's a whole bunch of case studies. There's a whole bunch of resources. There's a toolkit. And I'm working on revamping that. So there's going to be a new one coming out soon, which is kind of like the quick short version that you want to just have on your desk as a reference for the strategies. But you can also reach out if you want to advocate or volunteer. And then also for anyone that's actually professionals in this space, we can take action through our project. So I think there seems to be sometimes a misconception that people think, well, the only way to take climate action is I have to go out and protest, right? And the reality is you can take action through the things we build, the things we design. Nobody, that doesn't actually require any policies for you to do that. You can just make those changes on your own. We don't, when we work with clients, we don't ask every single decision that's made, right? We make a lot of choices as designers. So that's agency. We can do that. And so the more you help to educate yourself to know what these strategies are, the more you're actually taking action through your work. And obviously, the more of us that do that, is helping to advance the greater collective good. But also, if you're a homeowner and you have a backyard or you're working on a project, you can implement these same strategies at any scale, right? Backyard to the whole world. So keeping that in mind, it all adds up. As I mentioned, the municipalities and policymakers, we need support. We need support in new codes and standards, and there are many of us that are willing to help with writing those. And then of course, philanthropists too, because these are all free guidance and resources. So anybody that's willing to support, I have a GoFundMe site, and and actually that's part of how it happens, right? Even if somebody donates $5 or $100 every time that's made, we say, okay, what's the next thing on the list and how we'll improve the app? This is like 20 people have asked for this thing, so let's do it with this $100. So that's kind of part of how we can take action on our own. And so I think just lastly, to close this thought, that although I have talked a lot about carbon, that climate positive design isn't just about carbon accounting. There's this idea that when we sequester more carbon than we emit through climate positive design strategies, we can create this whole myriad of co-benefits that ultimately protect and support the most vulnerable communities to climate change, whether it's through supporting the biodiversity crisis or cleaning water, cleaning air, keeping our cities more habitable and livable. So all these things add up. And I think that's really the idea that we're trying to embody with climate positive design is let's use this venue to take action and do this through any vein that we can, and collectively we can make a difference. So thank you very much. That's it for me tonight.
All right, where'd it go? Don't know where the mic went, but we have time for some questions.
Ask the online people to just raise their hand.
Okay, online people, please raise your hand. Rich will tell me. Any questions out there for Pamela? Sid.
How does construction waste play into those kind of?
So it's currently set up as cradle to gate. And so it's factored in the upfront cost. So waste that's developed in the embodied carbon values in the manufacturing or extraction of materials, that's factored into it. We aren't going through the whole life cycle at this point in time in terms of if the project gets demoed. I'm not totally sure which end you're thinking about with the waste. So it's captured currently kind of in the upfront waste aspect, and that's part of the environmental product declaration, global warming potential values that get reported.
Okay, there's a question online from Sarah. If you just ask Sarah, you should be able to talk to the room, I think. Yeah, all you have to do is speak in the microphone. She'll speak right at it.
Okay.
Hi, can you hear me?
Yeah, perfect.
Okay. That was a great presentation. Thank you so much. I'm just curious, how did you come up with the initial data or numbers to represent each type of material for carbon emissions or sequestering?
Yeah, it was not easy. That was the gap really. And a lot of the values existed for buildings, for architecture materials. And so there were some data sets for commonly used building materials that are in buildings themselves and in landscapes. So things like concrete and things like that. That's where the data is coming from, the Athena impact estimator. But then there was a lot of materials that were, or things that were harder to find. And so those are coming from, environmental product declarations, if they're from actual products or peer-reviewed public white paper publications. But then also, as I mentioned, the numbers from the US Forest Service on sequestration. And then the good part about the fellowship that I forgot to mention is that it was, I had a little shoestring budget that I could actually bring on an environmental consultant. So they really helped me at that point in time to get the latest values that exist out there that are publicly available and make sure that they align with industry standards. And so those are still constantly changing and trying to update them once a year. But that was the hard part. Nobody had really pieced all those puzzle pieces together before. So it's still a work in progress also. Another one.
This has been very exciting for me. I was trained in the 20th century, and what I carry around with me is that I feel like this topic, this information, this means is redefining beauty. Right? What we thought was beautiful yesterday in terms of like our marble floor is now different, right? And my brother lives in Alameda, and he's always wondered what they could do to this middle class part of San Francisco that has all these rough edges. He's going to be blown away, but also really pleased, right? And my question is, as you make your way around the world, is there some condition, existing condition in an urban setting, wherever you might go, that is an idea you would love to turn into a kind of like the edge of San Francisco, like it's ready for something really, really important?
Yeah, well, I love your comment about this is redefining beauty, because I think that's absolutely right. And just to touch on that for a minute, actually, we have a cultural ideal here, especially in the United States, that green is good. And the reality is that high maintenance lawns in really wealthy neighborhoods, those are net emitters. They look green, but they are emitting more than they're sequestering because of the chemical fertilizers, because the maintenance. It's a combination of things that it's actually bad. So when it is this thing when I start to walk around, like I kind of cringe, because I know that that's actually, well, it does serve its purpose in definitely some ways to program that I see it with a different light. And for me, it's not beautiful anymore. It's part of the problem. And then so to your second point, I really get excited when I see like vacant parking lots or abandoned spaces like on Alameda, because they're so ripe for opportunities, especially, I mean, coastal conditions are super interesting as well. We have tons of them in Boston where there's a paved, underutilized site, and then maybe underserved community where we can actually depave and transform it into something that's going to be part of the solution, sequestering carbon, supporting the biodiversity crisis. We can make a place for people, and it can have so many other benefits, and you really just kind of need a jackhammer. So, so it doesn't also have to be crazy expensive. So I think those are the things that get me really excited, and I hope maybe can inspire some of you all and some of your project work too, because we don't have to overcomplicate this. Actually, the solutions are pretty clear. So, yeah.
So I have a comment and question. One is for all of you landscape architecture students who are out there, there's a new landscape performance class coming on that is much about this. So stay tuned, and you will be required to measure your design projects in advance of building them, and also to get a good grade. But Pamela, can you tell us a little bit about how this work and these topics are merging with policy?
Yeah, it's huge actually. So I think that's one of the, I have no tech background, full disclosure. I know enough knowledge to get in trouble basically at this point in time. But one of the benefits in working with an app developer, web developer, with basically friends of friends, is that, early on, at least I recognized like we need a way to kind of capture this, to understand it, and didn't know exactly what we were capturing at the point in time. It's just like, let's just collect it all, right? There's a privacy disclosure on there, so no information is shared publicly. But now what we're able to see is, 3 years in, we have the only data essentially in the world on these projects, and 5,000 to 800, however you want to look at them. But with these numbers now, we can start help policymakers say, okay, there is carbon policy coming in cities, it's coming in buildings, it's happening in Europe, where cities are saying, this is the maximum amount of carbon emissions that you can have for your building, per your square foot of your building. And it's just a matter of time before that starts translating into exterior built environment too. So whether it's infrastructure or landscape. So I'm working with those cities, and now we have the data we've collected to say, look, this is where we are in terms of our emissions per square foot and sequestration per square foot. And you can actually, as a municipality, say, this is the max that you can have on your project. And without having that data that exists, it's really hard to make those policies. But once you have, that kind of level of data to say, like, we have the 800 or 5,000 projects to reference, policymakers can start say, okay, well, actually, we're going to go with that as our starting point for this new policy. And so I see that coming really fast, actually. And I think a lot of people are maybe going to get caught off guard because, you know, it's coming down, it's coming from a lot of different levels. I think with the Inflation Reduction Act, there's many cities that have climate action plans out there right now. So it's coming at a lot of different directions. So the benefit is is to get on board as soon as you can, so you're not caught off guard, would be my recommendation to people.
So question in the back.
Thank you for the wonderful presentation. My question is that you did mention stuff like stone, if it's traveling from different parts of the world, then it becomes really problematic if it's in the US, but in many other regions where it's locally made or sourced like bricks and stone, does that make it a good material being used in those regions? Or there should be an alternative for it?
Yeah, it's better. So, you know, it's 15 to 20% better if you're using a local stone. The problem with stone still is that it's highly energy intensive to extract the stone, to move it around, to cut it. And so it still falls into a pretty high emitting category. You can use stabilized crushed stone is a good low embodied carbon material. You can add a stabilizer to that, and in many places that's considered an accessible surface. And so and that's stabilized crushed stone paving is just like stone fines are kind of like ground up. And so that's one good option, but that's actually another really good opportunity for manufacturers where we need more products that have lower embodied carbon, because it does start to, you know, we can use engineered wood fiber instead of rubber on playground surfaces. So you'll see, like, when you go through the tool, I mean, there are options, but you're right, it does start to, we could use more low carbon material options actually.
Curious
Yeah.
about the application of mass timber. As a
Yeah, well, definitely. I mean, there are a lot of conversations going on around wood right now. It definitely has lower embodied carbon than a steel beam for buildings. We also know that longevity is a thing too, right? And so we can't necessarily use a glue lam beam that's meant for an interior building outside. But so you have to make sure that it's treated in a way, or not treated, that or you understand how it's going to stand up against the exterior environment. But generally, wood has so much lower embodied carbon than concrete and steel. We're trying to use as much wood as possible, but also making sure that it's coming from sustainable sources. So whether that's from, now I'm blanking right now, sustainability certifications for timber. And I think because we want to make sure that we're not using tropical hardwoods, that we're not using wood from the rainforest is being cut down. So FSC, that's what I was thinking about, certification programs. So making sure that how it's being done, how the wood is being collected is being and sustainably managed for us.
One more question? Yes, one more. One feeling about Boston, Boston. The South Boston. One people around me told me that after I visit there, it's like all the Bostons building and playing. So I think the picture for me is not many green from the building of it's just concrete and the process. Actually, the houses are lovely. It's really good cleanliness. I hope in the future, architect can change some of that. I agree to that evidence. And then I have one question for your slide. You have one slide shows are you talking about basically doing something work to reduce the emission?
Yeah. So, and just for everybody, in case those folks online didn't hear the comment, there was a comment about South Boston, right? That there's not a lot of green, right? And so lots of concrete, lots of buildings, infrastructure. Just to address that for a minute, I think there's huge opportunity for urban afforestation, for us to start infilling cities with trees and plantings. That's being done in lots of other cities, and it's very effective. I know that there's an urban forestry plan, I think in Cambridge, maybe Boston too. It's
Absolutely.
everybody's working towards that. So I think there's lots of opportunity. It's kind of just a matter of, you know, getting those plans into place and going through the process. And then your comment about the cities. So yes, I've been working with other cities to start. There are many cities that have climate action plans, and many of them that now have goals for urban greening. So not just for sequestering carbon, but also reducing urban heat island effect, and supporting biodiversity crisis. So there are lots of cities. C40 is a wonderful organization that we've been collaborating with in Toronto. So the cities come together and have these conversations about, okay, what are you doing? Do you have a new code? How are you implementing this? What are the challenges? And they talk to each other in these kind of convenings. And so that's really great that they're supporting each other, but it's also kind of a little bit of positive peer pressure too. So cities will say, oh, you just implemented this new urban greening, or oh, you implemented this new code for sequestering more carbon. And you'll start to see once cities start that policy in place, it's much easier for other cities to replicate it too. So there is kind of this positive network that's happening within cities too. So help scaling up.
Thank you.
Yes, let's please give Pamela a round of applause. Thank you. It's one.